get to see you. We're looking forward to having you come back and visit us. Please make yourselves at home. We do a lot of things here. We work with 54 different languages. So we have all types of programming going on to suit those needs, as well as programming for seniors down to toddlers. So we're very excited to have you here. We hope we get to see you. Please, if you have any questions, just let me know. But welcome to the Dallas Public Library.
Okay. Okay. Okay, cool. All right, so let's dive in. I'm excited about this building. I'm going to share a little bit about our journey. Do we have slides? So my discovery of this facility came from a question from our Office of the Bond Program. And they said, you know, if we're going to be, yes, how can we, so if we're going to be net zero by 2030, can you help us get the specifications pulled together for our next bond program? And I'm like, yeah, sure. Well, then I started digging. And in the meantime, I got this award from the Dallas AIA for being sustainable, which was on the same program as an award for this facility. And so what I did was reached out to the architects that did this facility to get more information. So this is part of our journey. We could go ahead and move to the next slide, maybe. So I reached out to the architects, and what they told me is that, well, by the way, that facility actually is net zero carbon. We have exceeded the minimum requirements for the city of Dallas's green building policy. They're working on it. Yes, all three tiers. And that's important because many times some of the upfront costs for a net zero building are greater, but your return on investment is typically very quick. And it embodies the operational carbon moving forward, which is where you find all your savings, really. So back about 2 years ago, we were doing our CCAP plan. We did an emissions inventory, which we're in the process of updating right now. But buildings and energy formed about 64% of our emissions in the city of Dallas. Next slide. So it's a huge thing, and it's really important. We have targets, and one of them is net zero energy construction by 2030. And then to ramp up our energy use, not ramp it up, but ramp up savings in energy use and tackle that over the next period. Next slide, please. So there's our target. Our own architects reached out and said, help. Y'all know more than us. And then y'all may have heard we're kind of redoing the downtown convention center. I think it's a $2 billion project. We spent the better part of a day with their design team, and we discussed all things energy efficiency, all things really climate related for that facility. They really want it to be cutting edge. And that came from the design team, and it came from also our own convention center and special events folks. And so we're moving forward on that. Next slide, please. So one of the actions in this year's implementation plan is to update our building code. My friends in the development services group are working right now on updating to the 2021 building code, which is a good start. Next slide. No, we're trying to get it done before then. So we have to have the code in place to get the buildings in place by 2030. So we're working on it now. No, we're not waiting to 2030. As you know, city timeframes tend to extend, and so we're starting it now. And I will also say that this is one of many city policies that are more sustainable than you would think. The city of Dallas actually had a green building policy well before our neighbors down I-35, starting in 2003. But we haven't updated it for a few years. And as we start looking at some of our more recent policies, such as sustainable procurement and our own CCAP, the Comprehensive Environment and Climate Action Plan, we have some work to do. Next slide, please. So these are the different codes I get to play in, except that I'm a civil engineer, not an electrical or mechanical or even an architect. And so I am working with friends in those affiliated places to make this happen. Next slide. And you will note that our existing green policies are a couple versions out of date. I think we're still on 2014, 2015. In the meantime, there's a 2018 and a 2021. We skipped 2018. We're looking at, and our sustainable development guys are looking at 2021. I recently attended the Texas Energy Summit, and the folks that were talking building codes there are talking 2024. I don't necessarily want to wait till 2024 to do this. I need to do it sooner. So we'll do it sooner now and fill in the pieces with policy. Next slide. So this is just some of the stuff that we've got in our current green building policy. That's the Keast Recreation Center. You will see that it's got a fairly good sized solar array. I don't remember how big it is, but it's a pretty good sized one. We already line up pretty well with LEED as it is, or has been, but LEED itself is moving forward. Next slide, please. So one of the other things that the mayor in particular was interested in is green roofs. And so we provided, this is part of the information that we provided to our environmental commission. And I see some of our commission folks here today. So they'll be familiar with it. The top is the roof on the Perot. The middle is the construction photos from the Audubon, and then the bottom is actually the Dallas Fed building. I don't know if you can see it, but the hardscape on their green roof is actually a $, which I find really humorous. So anyway, so we do have a cool roof policy, whether it's reflective surface or green or actually blue, although typically we don't see many blue roofs. That's water storage, mainly because of the load and the potential for leaking. So, and the local roofer, many of you all know, he's part of the solar tour. Arrington's Roofing has worked with Texas A&M with a zoysia type grass that requires a shorter root zone. And so it's not as much weight on the roof structure. Next slide, please. So I started rooting around trying to find stuff. I talked to the architects that did this facility, and they told me, well, we're part of AIA 2030. And I'm like, what the heck is that? And they said, well, most of the architects in the country, at least the better ones, have already pledged to do net zero by 2030. They're already there. And so the design on this facility was done. I'm sorry. You're fine. Just you're making me dizzy. This one. You're fine. So the whole thing with their program is to get to net zero carbon. They are looking at energy use intensity. They are looking at passive design. This facility is located passively. You will note the windows are all on the east. This is a solid wall on the west and the south. And so they're looking at that. They're looking, typically the architect comes up with the design and then the engineers scramble to make it work. They're working as more of a cohesive design team from the get-go so that we're building a little bit smarter. And they're also doing energy modeling as a part of that initial design. Next slide. So this is where we are. This is an 18,000 square foot library. The challenge is this is in an extremely diverse area of Dallas, extremely in a good way. This is one of our prime welcoming communities. A lot of immigrants, when they relocate to Dallas, are here. They got neighborhood input into the design. They wanted the library to be a welcoming place, and it is bright and sunny and definitely welcoming. So the total cost, and this is from some information from our bond office, and I'm a nerd, I did the math. We're just under 9 million for the total cost of this facility. But as you can see, they used multiple sources to get this to happen. It was recently completed in November 2020. Unfortunately, because of COVID, it didn't open physically until last spring. And it's in Council District 13. It is registered under LEED version 4. But again, when I spoke with the architects, they're like, well, y'all have the green building code. It's consistent with that. We really went above and beyond. And so I'll show you some of the features of this library that I really like. Next slide. So one of the things, and I'm sure this was a nightmare for my friends that are structural engineers, but when we did our climate plan, we worked with the insurance industry on risk evaluation for Dallas. Our highest risk in a future climate is damages from straight line wind events. The structural shape that is most resilient to that is a curve because it deflects the shear. And so this library is curved. It also has continuous insulation, which from an energy saving standpoint is huge. Next slide. What? It Thank you. So one of the other things, and for those of you that are used to farmhouses that have a nice porch that goes all the way around, this is kind of brought to a modern aesthetic, if you will. They have deep overhangs. Again, it shades the building from the summer heat, but you still get the light, which is natural light, which is also healthier. Next slide, please. And you'll notice that, I'm sorry. Okay. This one. So I am a civil engineer. I've been working in our stormwater group. We have been focusing on native plants, on green infrastructure, on permeable materials. And this does my little civil engineering heart good because they incorporated all that. You'll see that with the exception of the turf there, most of the plant materials are native. Most of them have open areas that can infiltrate water rather than promoting runoff. Provided mainly because of the proximity of DART lines. So we're trying to encourage greater use of transit to get to this facility as well. Okay. Yes, sir. Oh, I'm sorry. I can't hear you. So I'm just making up stuff. Okay, so we can move on to the next slide. Okay, so the other thing, and this is where the Ms. Ramirez from the library also mentioned this. So the flooring is actually raised so that they can do the HVAC in the sunken part, and they can also use more local materials. And those are both LEED categories that they have gotten full points for. The other thing is, and you can tell, there's a lot of natural light coming in, and they've got the upper clerestory that also supports use of natural light. And then the lights we do have, of course, LED, and that's pretty much a citywide standard at this point. Next slide. Okay, and this is the part you guys are all excited about, is the roof panels. I got an email with a really excited photo and message from one of my colleagues in the bond program when they installed it, because I had been begging for them to put solar, and they kept telling me, no, we don't have funding. And then all of a sudden there was solar. So I'm very excited about that. I counted 180 panels from the solar, from the photo. I believe it's around 43 to 45 kilowatts. I don't know that for sure, and I have not been able to confirm it. So when we go up there, we'll need to count, and I can hopefully get with the design team and get their confirmation of that. But it's enough for us to get midday savings on the power. I don't know that it's enough for it to be fully powered. The other thing that we've done is, this gets into the cool roof. We've got a high albedo roof, which is the white coating that reduces the amount of energy absorbed by the roof structure itself. Next slide. Yes. The question is, what is albedo? And that's just reflectivity of the roof. It's just a word. Yeah. Asphalt paving. Yeah. Melon. The question is whether there's a monitor in the library so that you can, somebody visiting the library can see how the facility is functioning, and I have no idea. And so it would be a good idea. I know that this building is on our energy management system. We are tracking that. It's, I believe, ISO 5001, which is a recently implemented system that we have. We've done energy audits on 140 of our facilities at this point. We have 800, so we have a ways to go, but that program has started.
And she would love to have a live monitoring to be able to show the visitors here.
Okay. Okay, we can try that. Next slide. I promised I would be short, and it isn't. Okay. I think so. So these are the list, and it's a partial list of the codes that we're looking at moving forward to get us closer to net zero carbon. Next slide. And I know we have folks in here that are building code people, and I will tell you right now, I would absolutely love your help on this. This is another thing that we just did. The mayor asked us about it. Interestingly enough, the city manager asked about it, if we could do it. I will be honest with you, it is a stretch. So US Department of Energy just recently implemented a program across the country. 80 people signed up. We are the facility that's a city that signed up in Texas. So it is to have 50% of our buildings net zero in 10 years. We are tracking those initial 140 buildings that we have energy metrics on. The whole program is focused on reducing our energy intensity in our buildings. I'm all over that. It will help the city reach those net zero goals by 2030. And so the other thing that it does is helps us leverage public funding, and it gets free advice from other cities and from our partners at the Department of Energy. So I'm extremely excited about this program. Next slide, please. So these are the cities that right now have net zero goals. My friends down I-35 are on this list. However, I'm a nerd, and so I was poking around in their codes and I couldn't find anything in their codes right now. So they may be like us and working on it. But anyway, so it puts Dallas in pretty heady company relative to our relative climate goals. Next slide. And the other thing that you will note is I am not an architect. I am not a mechanical engineer. I'm not an electrical engineer. I'm a civil engineer with a lot of friends. And so I reached out to Dallas AIA. They already have a committee on the environment, and they are working with Carbon Futures League to assist the city in implementing CCAP. And so we now have a working group with them to help develop those recommendations towards net zero carbon, all three areas. We've had a couple meetings now. That's how I got the slide before, as I was researching who else doing this and what we can cheerfully plagiarize and not have to do ourselves. But we're meeting with them. Our environmental commission has asked us to come back for recommendations this fall. Our environmental council committee has requested that we get something on the books relative to an updated green policy for at least city facilities before next May. And so I think they're looking at this fall as well. The idea is to raise the bar on our green building policy for our own work, implement the 2021 building codes, and then take a look at, I don't want to say making people, because that sounds kind of harsh, but raising the bar relative to our development codes so that they're also ultimately net zero carbon. That will be a harder pull, and I will likely be calling on many of you for help to that end. Yes. That's a great question. So the question is, what do you mean by net zero carbon? Is it the carbon from construction, or is it the carbon moving forward? What we are looking at is both the embodied carbon, which is the carbon that's in the materials and the construction, and then operational carbon, which is the carbon that is used in that facility going forward. So are you able to get away from fossil fuels? Can you rely wholly on renewable energy? How are you maintaining your building? And are you looking at your carbon use on that as well? So it's a really bigger picture of your building than just your initial construction and construction costs. Does that make sense? And so in my mind, it's a better use of public funding because we're looking at that bigger picture. I believe it's a normal building. Oh, the other question is over what time frame? We're looking at it over the building life, which is typically 30 to 50 years in the United States. That, yep. Yep. It's a life cycle cost.
Susan?
I'm sorry. Yet? Oh, the question is there a program for net zero carbon for residential construction? Not yet. That's where it comes into being when we start looking at the codes. That said, we have some commission members and some folks on our technical team that are building net zero homes right now. Alan Hoffman is a pretty well esteemed builder in the Dallas building community. He actually is having an open house on some of his homes on April 4th so that you can see some of the net zero homes that he's constructed.
Susan? Hello?
The question is whether we can include information on some of these homes on the website. Certainly. I'm sorry. I'm lost. I've got the 3 or 4 different voices. So
This tour of
I'm sorry. No, that is something that Alan Hoffman is doing to increase. The question is whether that home tour is something the city is doing. Not officially. He is one of the members of our environmental commission, and he's doing it to help people understand state of the art relative to residential design and what is possible. And I'm very appreciative of his offer. So this is kind of where we're at. Next slide, I think, is my question slide, and we're doing that. Is whether we're looking at that for existing construction as well, which is in the retrofit category. After I got my last gas bill with $100 in surcharges for $20 worth of gas, I am currently looking at taking the next step towards electrifying my own home. We are focused on the city mostly on first our own facilities, then other larger commercial institution, and then residential, just because it's easier. It doesn't mean that that's where the market is or we don't care. We do. And as we look, we have been challenged not only for new construction, but retrofits to make them net zero as well. So it is something that we're taking into account on our own construction. And I think the big selling point is that end of the day bottom line. There is such energy savings by going that direction. It affects the bottom line, will allow us to do some other things.
is this building geothermal?
No. The question is whether this building has geothermal, and I don't believe they went that route.
I don't see how I have one solar panel can ever disconnect from the grid simply because I have air source heat pumps. When it got cold February, my energy demand went through the roof at minus, you know,
2.
when we got below zero.
Mm-hmm.
Even though I opinion that if we don't start going full-blown geothermal sources, we are not going to get
We are looking at geothermal at the Hensley Field project and some of our other projects. It is a part of the equation. It's just not as popular as its other cousins. But except in Kansas,
they're all,
I don't know that I would go that far, but yeah.
but they have to deal with coal. And it turns out like demand is higher.
Actually, the highest energy demand Dallas has ever had was in Winter Storm Uri. And so one of the pushes that we've got, our climate plan is being implemented under a lens of equity. 40% of our residents are in energy poverty, which is more than 10% of their income is being used for energy. One of the things that even the Federal Energy Commission looked at was the effect of having substandard housing stock on that energy demand. And so one of the things we're really looking at right now is how to work with Encore, how to work with the county and others to raise the weatherization of our housing stock overall. That's a big deal. That's 90% of it. So we have all kinds of things going, different realms on ways of fixing it overall, but and actually any one of those topics could be a whole conversation, but
And then it's bigger back to it. Routes where heat comes from. That's the problem.
yeah. Okay. That's all I've got. Sorry. Thanks, guys.
How do you convince them? Are you
We don't have them yet. We will. And this is interesting. We have some council members that have asked us for a big proactive multimedia media campaign. I have a budget of $50,000 for outreach and engagement. So I'm just saying, I will use all the help I can get. One thing that I will mention is that we consider the library to be a very important partner. One of the things that we did during COVID was to work with the library to do virtual outreach and engagement sessions. And a lot of parents loved us because they had kiddos at home. But we, every Thursday, have Earth Day every day. We have all kinds of different presentations. I would love it if we could also partner with NTREG to develop and put on some presentations related to energy efficiency, to solar, heat pumps, both air and geothermal. There's all kinds of things and topics that we can work with our friends at the library to get out on the street. And I would love it if that's something that might be of interest to y'all as well. And I'm happy to put your name on stuff as well, because I consider NTREG to also be a great partner for the city.
Okay, how about now? Huh? Okay,
We can hear you
don't cover
now.
my ears, okay. Okay, you want to do that first then? Okay. Okay. All right. Okay, yeah. Okay, so we have Mike in the room. Yeah, okay. So the next presentation is by Mike Renner, Mr. Do-It-Yourself and Self-Sufficiency and Energy Efficiency and Energy Independence. He's done a marvelous job of basically living off the grid and generating all his own electricity. And so with that, I will turn it over to Mike. Can you hear me? While they're doing that, my name is Mike Renner. I'm not a professional installer of solar. My background is aviation electronics. I have a background in electronics. Before aviation, I used to do home entertainment electronics. So my major background is in electronics. I got into solar by accident many, many years ago when I read an article in a Popular Mechanics magazine and built a little small window solar box. And it worked to heat one little bedroom. And ever since then, I've been hooked on solar. This was 30 years ago, maybe. And I've been finding ways to improve it and learn as much as I can. One of the best tools that I used to use was a magazine called Home Power, which they're no longer publishing that magazine, which I'm sad to say because there was a lot of good information in it. But everybody has access to a good new tool, and that is YouTube, believe it or not. There is a lot of information on YouTube, but you have to learn how to decipher which is good information and what is not information. Just because it's on the web doesn't mean it's good information. So you have to do some research. And a lot of what I do is research on YouTube, mainly for different components and things that are out there that I don't know about, because I'm always trying to improve my system. So YouTube is a valuable tool that I use to learn stuff. And just because they say something on YouTube, I go and try to find to make sure that that is actually what they're saying is true. There's a lot of stuff that's not, so you have to do research. And anybody in here I know has the ability to do research. And to be self-resilient, you have to get out of your comfort zone. We're all so used to turning on the faucet, turning on the switch, and we have a whole crew of people at the water department, electric company, that's all doing everything for us. It's a good idea to get out of your comfort zone and learn how to do some of this stuff yourself. And everybody has the ability to do this. Everybody, every one of us. First time you had a flat tire, maybe you didn't know how to change a flat tire, but somebody showed you. So next time you were stuck on the road, you could probably do it yourself. We all have the ability to learn how to do stuff. So this is my progress and what I have done over the years to make myself resilient against power outages, between water shortages, and we even produce some of our own food with greenhouses. Everything that we have at our house, I have personally built, including the house. And this started out back in 1992. The company that I worked for was in the process of a merger. And a lot of us were fearful of our jobs. I had a big house, a mortgage and everything. And I said, well, if I lost my job, how am I going to make home payments or whatever? At that point, we decided to buy some land. And it took off from there. I figured if I lost my house, I could always move into a trailer on the property that I bought and then slowly build. And that's where it's actually started at. So I've been a member of Texas Renewable Energy Group for, oh gosh, I don't know how many years, a long time. And really learned a lot here from a lot of different people. So there's learning opportunities everywhere. So being able to be resilient, you have to be able to adapt from different misfortunes and things. And part of that is preparing. For instance, if there was a power outage in the middle of the winter, if you go to the store to buy propane, either it's not available or there's long lines and you have to wait out in the freezing cold. And to be able to prepare is to think of things that's going to happen 6 months down the road. Buy things that you need in advance in order to prevent shortages when you need it. Now, propane, when I've seen people out there when it was real cold and 13 degrees outside, there were lines and lines for people looking for propane, and you stood in line for hours and hours, and you got halfway through the line and they ran out. And that happens with the little propane bottles that you could buy at the store. You can use propane in the house, the little one pound bottles for heat and for cooking. Have to buy them in advance and store them. They don't go bad. Okay. That's part of being resilient, is being prepared for what could happen. Now, there's a lot of things that you may not know what happens. So, but being prepared for basic things is very important. So next slide. Oh, sorry. Okay, part of what, when I first moved out there, we were in the middle of a drought and there were wildfires everywhere. And one of the priorities I had was to make sure that my place does not catch on fire and burn down. In order to do that, you have to have water. In order to have water, you have to have electricity. Normally when there's fire, it gets up against the power lines, power poles catch on fire, you're out of electricity, you can't pump water. My goal was to make sure I had power to be able to run my well in case there's fire. And that's my main priority, to have a battery backup system to be able to provide myself with water, not just for firefighting, but in case I'm not on a city municipal, we don't have water from the city anywhere, we have our own water source. Power is very important in order to provide water. So that was my main goal for getting started, is to make a system that you had power 24/7, no matter what. Are we there yet? Okay, right there is fine. Okay, so to be self-resilient, there's many different things that you can do. First of all, what is it that's important to you? What do you need in case the power goes out? Has everybody here experienced power outages over the last couple of years? First of all, it's frightening. Then the next question is, when's it going to come back on? Nobody knows when it's going to come back on, right? If it's in the middle of winter, your house starts getting cold, your phone might start running dead. Your internet goes out. You have no communications with anybody. So you can start off with small things. There's a lunchbox back here that I had built on steroids that you could use to provide lighting. You can charge your cell phone. You can keep your laptop going. Just a simple, basic, small little system. You can charge it up by the grid when the power comes on. You can charge it up with solar panels if the sun's shining. Or you can, even if you have a generator, you can use the generator to charge it back up. Generator is not a very good idea, but it does help out. So there's many different ways that you can provide yourself with power. But you have to concentrate on what your requirements are, what is important to you, okay? So, and that will determine the size of your system, of what you can do. And you can also make a system that is over a period of time that's expandable. You can start off small and you can grow it over a period of time. And to me, that is very important. Instead of just buying little small things and then replace them and buy bigger things, buy something big enough that you can grow into, make it bigger over a period of time. You can save yourself a lot of money. Plus, it adds greater capacity to the system. If you add more devices to it in surges, it really makes a big difference to grow your system over a period of time. And plus, the upfront cost is not as much because you can grow it in increments year by year. Next slide. This is the lunchbox that you see back there in the back. It's very portable. It's lightweight. Well, fairly lightweight. You can pick it up with one hand, but it is fairly heavy. It has a lead acid battery in it. It's a 35 amp hour lead acid battery, excuse me. But I purchased a lithium ion battery. Well, not lithium ion, it's a lithium phosphate iron battery, which is a lot safer than a lithium iron battery. There's no chances of fire or whatever with these type of batteries. They're safe to be inside. That one there is very heavy. This one here is actually almost double the capacity of that one. Iron or lead acid batteries, you can only realistically discharge them halfway and charge them back up in order to increase their life range. This one, you can bring it all the way down. So the capacity is actually twice as much, and it's very, very light as compared to a lead acid battery. There's a same capacity lead acid battery back there. I challenge you to go in there and pick both of them up and feel what the difference is for them. It really, the cost on the lithium is much more, but the longevity of it and the amount of power that it produces will outperform the lead acid battery in cost over the period of time. So that's something to remember. Yes. I believe that one that's a 50 amp hour, I think it was around about $150 to $200. So they are more money, but like I say, you use one of those in place of maybe 3 or 4 lead acid batteries. Maybe not that one, maybe another size bigger. It depends on, I might start a 4-cylinder, I don't know. That is designed with a BMS in it, which protects the battery, and the BMS is designed to only put out 50 amps. And your car will require a lot more than that. BMS is a battery management system that is built into the batteries that prevents the batteries from being overcharged, undercharged, and over temperature. Now, the better batteries also has a low temperature charge controller in it or a sensor in it, where if it gets below freezing, you're not supposed to charge those batteries, you can ruin them. A lot of the batteries on the internet do not have cold weather protection in them. So you have to either store them in a warm place or make sure they do not charge when it's cold outside. You could always add a heat source if you need be. So it can work, depending on where you have it. Like I say, these are safe to be inside. So in a climate controlled area, they'll work very well. Outside camping in freezing weather, maybe not so much. Next slide. Looking at different sizes, that's a small unit. This is a medium sized unit. This is a solar trailer that I have built that we've used on many trips that we've gone to. I powered sound stages with it, different bands, all sorts of different things. When it's in the house or at my house, it helps produce power for my house and interconnects with the systems that I have at the house. So it's always at use. Next slide. And of course, this is a bigger system. It's a whole house system in conjunction with a trailer and also some yard mounting systems I have. As you can see, it was a cold winter day when I took that picture. The snow has already melted off of the panels. Panels are dark. They absorb light even through the snow, and the snow has a tendency to come off of them real quick as compared to everything else. So even in the wintertime, the panels do work. Even if it's cloudy out, the panels still produce some heat for the snow to slide off of them. Next. Some of the basic tools I use to put together systems. Some of you may be familiar, some of them may not be familiar with some of these tools. Most hand tools and drills people have, meters, wire cutters, saws, torches. I use a torch for soldering heavy lugs for batteries. So I'm not going to get into a whole bunch of how to actually design a system. There's some deals on our website that shows how to do that I've actually created. That was for a solar generator that I've built for the group. Next. Uh-oh. These are some of the components. The basic components you need for a system. First of all, you need a battery for storage. And you have to size the battery for the use that you're going to be using it for. It's important. Well, what you're running and how long you're going to be running it for. Next, you have a way to keep that battery charged. Solar panels can keep that battery charged. You can also use the grid to keep that battery charged in case of emergencies. If the grid comes on for a short period of time, you can charge it that way or with a generator. So you have to have a charge controller. A charge controller will actually prevent the batteries from overcharging, and it's very important to have one. And then you have to have solar panels to provide the power to the charger in order to put power back into the battery. Those are the main three components. And of course, you have circuit breakers and fuses to protect everything. Next. You can use a 12-volt system, a 24-volt system, a 48-volt system. You can see 36, but there's really not much 36-volt units out there. You can hire or put batteries in series or in parallel. You put them in parallel, you can increase the amperage hour. If you put them in series, you can increase the voltage. The higher the voltage, the less amps you're going to draw out of the battery, the smaller the cable size, which means the cable size can be cheaper for whatever you're using. I do the same thing with solar panels. Watts, volts, I'm not going to get too much into that other than the power that we all buy is rated in kilowatt hours, which is energy. Power is what something can consume instantaneously, like a 60-watt light bulb is rated at 60 watts, but over a period of 10 hours, that's 600 watt hours. There's a difference between power and energy. You need to know how many watt hours you're going to be using for how long in order to size your battery to use overnight. Now, during the daytime, you have enough solar that whatever devices you're using, you can use your solar panels to run your devices without even touching the batteries all during the day. They stay full. And by the time the sun goes down, your batteries are full charge. And then what's remaining, you can use at night. And normally at night, what we do is we cut our energy use at night. We use most of the main power that we use during the day, which includes running heat pumps, running water heaters, everything that is large energy draws, we use it off the solar panels and not off the batteries. That maintains a long life over the batteries. That way you don't have to use them at night and run them way down and have to recharge them half the day to bring them back up the next day. On an average, in the morning, when we wake up, our batteries still have 80% of the charge left in them. And that really increases the life of the batteries. Yes.
What kind of batteries?
Oh, yes, sorry. What kind of batteries do I have? Right now, we have lead acid batteries. I started the system several years ago. Lithium was not really available. If it was extremely expensive. The batteries are starting to show their age. The main batteries I have for the house are now around 8 years old, which the way we use them, they last a real long time, but they are showing their age. So when it's time to replace them, I'm going to replace them with lithium batteries. And the equipment that I have is adaptable. I can set the chargers to be able to charge lithium or lead acid batteries. Yes. What type of lead acid batteries do I have? The house batteries are mainly flooded lead acid batteries. They are outside. They are in a protected box. They're old school technology. They do work. There's maintenance required by them. You have to make sure you have to keep the water on them. They do produce acids on corrosion. You have to keep that all at a minimum. There's a lot of maintenance required for lead acid batteries, but they do work. They're their cheapest source of batteries. But like I say, the newer batteries that are coming out will outlive them, even though the upfront cost is higher. The over length of the whole unit will actually be cheaper than buying lead acid batteries over a period of time. So right now we have lead acid. Next. I'm going to skip some of the math. I don't think y'all are interested in math. And I've talked a little bit about the difference between power and energy. Energy is power over a period of time. Wire gauges, of course, the more current you use, the more amperage you pull, you have to have larger wire. So if you increase the voltage, if you double the voltage, you can have half the current and really reduce your wire size. Yes. Okay, load calculations is you can buy what they call energy meters to put on several different devices. I have what I call a watts up meter. The question was is how do you calculate your loads? Loads can be intermittent or they can be constant. Take for instance a refrigerator. The refrigerator is an intermittent load. The refrigerator doesn't run all the time. It turns on, shuts off, it turns on, it shuts off. The more you open the door, the more it runs. I put this device on my refrigerator. I plugged it in the wall, plugged my refrigerator into it, ran it for a period of 24 hours. My old refrigerator that I had consumed 3 kilowatt hours per day, which was pretty high. I bought a new refrigerator, replaced it, did the same test. It now only draws 1 kilowatt hour per day. So, and it can show you the cycles of when it goes off and on, off and on. The one thing I did learn about refrigerators is they're pretty energy efficient. The time they use the most energy, believe it or not, is when they do the defrost cycle for the freezer. There's a resistance heating element in there, and it may spike up to 400 or 500 watts at one time for a short period of time. Which, if you're designing a system to run your refrigerator, you have to keep that in mind to make sure that whatever you design will be able to handle those spikes of current for a short period of time. So that's an important calculation. So a watts up meter is very important. It also, you can hook it up to your computer and it can show you exactly what power it consumes, when, and for how long. There's all sorts of different devices out there that you can buy, but that's one of the easiest things. You just plug it in the wall and plug your device into it and let it run for a day, and you can see what it's using. Next. We're going to skip all that. This is about wire, the different lengths of wire. Like he was saying, we have a 15 amp circuit breaker in the house. Most 15 amp circuit breaker requires a 14 gauge wire. If the wire is smaller than that, the wire can overheat. You can put a bigger wire in and you'll actually have less of a voltage drop at the end of the wire, which makes it a little bit more efficient. And at times that may be required because a 14 gauge wire has a certain voltage drop and it's based on 2% by the time you get to the plug. If it starts drawing more than that, because the length of the wire is longer, the resistance of the wire increases, you may have to go up in gauge in a wire. And there's all kinds of charts out there. You can do your research in your homework. It tells you how much feet you need per wire at a certain current draw. There's all kinds of information out there on that. Yes. They're a bad idea if you run them all the time. First of all, they're very high in pollution. They consume a lot of gas. When you need it, there may not be gas available. The plus side is if you have a battery-based system, you do not have to run a generator 24/7 to have power. You run it intermittently if your batteries run down. So in that case, a generator would be a good idea to intermittently charge your batteries if there is grid down and your batteries start running low if you have no solar. So in that case, the generator is a good idea. But to run a generator 24/7, especially if you're running light loads, is very inefficient and very costly and produces a lot of CO2. So it's best to couple one with a battery system so that you don't have to run it 24/7. Solar generator is the same thing. It's not a gas based. This little cart back here or this little thing is actually what they call a solar generator. You hook up a solar panel to it. The panel generates power that goes into this. Next slide. There's some of the crimping tools that I use for wires. You could use that. That basically you hammer it in and there's a gauge on it, tells you how far to go. Next. There's some of the crimps that I did for battery interconnects for connecting different batteries together. Now, again, we already talked about what size system you need, and that depends on what load you're going to use. Next. And also for how long are you going to have to run that load? You have to run it all night long? Do you have to run it for 24/7? All that has to be calculated in as to what you want to use it for. If you're just running a laptop, if you're just running a few lights, the load's going to be a lot lighter. But you're also going to be using the lights at night. You don't use them at day, so time of use makes a difference. You have to calculate all that stuff. Next. Different solar panels that are out there. There are several different types. Most of the ones that we use today are either the poly or the mono. And what I've learned about solar panels is price is dependent on size. If you buy small solar panels, they are very costly. You can buy a little 5-watt solar panel that's going to be around $30. That is a very high dollar way to build the system. On Amazon, you see a lot of vendors selling 100-watt solar panels for approximately $100 for 100 watts. That's $1 a watt. That's a little bit better than the 5-watt panels. However, if you start looking at solar vendors, there's one that I found in East Texas called Signature Solar. They had a sale on during December, and I was buying 400-watt panels for a little bit under $200. So that's about 50 cents approximately per watt on the solar panel, which that is a big price difference. So the bigger solar panels are actually cheaper to buy than the little smaller ones. Yes. Right, shipping cost is high. The question was, does that include shipping? That does not include shipping. Shipping is separate. What I liked about this is this company was located in Sulphur Springs, which was a close enough drive for me. I went and picked up the panels from them. Of course, I had to spend some gas to get there, but it was a lot cheaper than shipping. And the other thing that I've discovered about shipping panels, for some reason or another, the shippers, they wind up putting things on top of them or stepping on them. I've seen forklift marks on boxes, and the top panel is normally broken all the time. And of course, then you have to wait for another panel to arrive or whatever, but that does happen quite a bit. And you would think they would learn, turn in a claim, and the shipping company replaces them. But now if you're short a panel, now it's delayed what you're doing. So try to find them locally. If you find them locally, of course, shipping cost is going to be less, or you can go pick them up. So that's a good point. Next. There's some of the data plates on the back of panels tell you what the wattage are, what the voltages are, and how much current these panels produce. And that is important. You have to know how many panels that you can hook up to a regulator, because if the panels produce more voltage than the regulator can handle, you will burn up your regulator. I use MPP regulators, which is maximum power point regulators, which you can increase the number of panels in series, which increases the voltage going to the regulator, which may be close to the battery. So the current for the wires could be a small current with a higher voltage, and then the charger will take that voltage and step it down and increase the current going into the batteries. And you have to be very careful to make sure that you do not put too many panels in series or the voltage to be too high for the regulator and to be able to handle it. So it's important to look at the nomenclature or on the batteries or on the solar panels. And you have to look at what the batteries will do in a cold situation when there's no load on them. Because when you take a load off of the solar panel, the voltage is drastically going to go up. So you have to take that into consideration. Next. Circuit breakers. In a DC system, do not go to Home Depot or Lowe's and buy a circuit breaker from there in order to protect your batteries or your DC systems. AC breakers are not rated for DC loads. In an AC circuit, the voltage is constantly going off and on in a sine wave panel or sine wave. And what the breaker does is when it starts to open, it will create an arc. In an AC system, that arc is extinguished 60 times every second. And that arc will go out when that breaker opens. In the DC circuit, that arc never gets extinguished until the breaker opens up far enough to extinguish the arc. And most AC breakers will not extinguish the arc in the DC system. So you have to use DC breakers or DC fuses. Do not use AC breakers in a system like that. It's important. You can get them on Amazon. Where can you get DC breakers? Amazon is one of the big sources where I go to get just about anything. Or you can just Google DC breakers. There's a lot of electronic manufacturers that will do it. A lot of, or some of the actual square D breakers that are rated for AC can also be rated for DC, but you have to make sure you get the right ones. Google DC breakers. You'll be surprised where you can find them. Next. There's an example of some DC breakers. Outback Power makes DC breakers. They're rated at 150 volts DC, and you get various different amperages. Also, there's DC fuses, similar to car fuses. They're rated for DC. I don't like fuses because you can't reset them, and one of them goes out and you don't have a spare. Now you got to go find a fuse, but you can't do that. So next. The other question was, can you draw more than 100 watts out of a 100 watt panel? And the answer is yes. If you have a battery in charge in the circuit, you can draw 200 watts out of that battery. And as soon as you take the load off, that charger or the solar panel will charge that battery up. So yes, you can do that as long as you have a battery in the circuit. Some different type of batteries. I've got examples of some batteries over here. I welcome to go back and look at them. The lithium batteries, at this time, I wasn't aware of them, so you don't see any examples of them. These are the batteries that I currently have at the house. They're actually developed for the telecommunication system. And the way our cell phone systems works, when there's a power outages, our cell phone system actually works off of the batteries, so there's no interruption. When the batteries start running down, there's a generator at every cell station if the grid is down to keep the batteries charged up. So that way your cell phones keep working. These batteries are actually designed for that. They're actually lead acid batteries. I'm sure now they have probably switched over to lithium batteries in the cells because of longevity and no maintenance on them. Next. Some different characteristics of discharge rates of the batteries. The slower you discharge a battery, the more you can draw out of it over a period of time. It's like driving your car. If you have so much gas and you drive your car 100 miles an hour, you're only going to go so far. If you slow down, drive 50 miles an hour, you may go twice as far because you're using a lot less power at any given time. Lead acid batteries are just like that. Lithium batteries do not have that much of a problem. The internal resistance is a lot lower. Therefore, they don't heat up. Lead acid batteries do heat up. Heat is waste for energy. So with lithium batteries, that is not near as important as it is with lead acid batteries. Yes. Okay. All right. Okay. Next. This is also based on lead acid batteries, the depth of discharge. The deeper you discharge them every day, the less number of times that you can do that. That's why at the house, we use our big loads during the day, run them off the solar panels, use light loads at night. In the morning, we've got 80% left, which means we've only discharged them 20% of the time. So that would give me around 5,000 cycles to be able to do that, as compared to if I bring them all the way down and the cycles are a lot less. One important thing to have in the system is a battery monitor. You can find all sorts of different battery monitors on there. You have to know how much power you have left in your battery, how long can you run things for. A lot of them are based on voltage only, which is not a good indicator because you put a load on the battery, the voltage dips. You put a charge on the battery, the voltage goes up. And those units, they're not very accurate in order to tell exactly how much energy you have left in the battery. The way to do that is measuring the amount of current that you actually pull out of the battery and put back into the battery. And that requires a shunt. A shunt will measure how much current you're putting out and how much current you're putting back in to replace the amount of current. That is the best way in order to monitor how much of a charge you have left in the battery is through a current shunt. There's an example of a battery monitoring circuit that uses a current shunt. Charge controllers, I talked about the MPPT type, which is the best way to go. If you're going to use a small little system just to run one light or so, you may use a little short, small charger that's not a maximum power point charger. It's just a switching mode charger. If you're just going to use it to run a light, I have some of them that have outdoor lights that I run them by, that the lights can be charged all day long. And there's actually built-in timers with them to where you can set how long you want them to run at night. Those are cheap chargers. For a big system though, I would recommend MPPT chargers, which will give you a lot more power per panel that you're using it for. Next. Next. That's about what I just talked about on the panels. This is an example of MPPT charger. This one's rated for 30 amps. You can get it from Midnight Solar, and it'll be good for a 12-volt system, a 24-volt system, or a 48-volt system. And the other good thing about it is the voltage set points on these things are adjustable, so you can use them for different types of battery technologies. So most chargers are set at certain battery types that you can't always use them for. These are adjustable to where you can use them as per what your battery specifications call for. Next. 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 A little bit about inverters. There's cheap inverters and there's more expensive inverters. The cheap inverters are modified sine wave inverters. Your better inverters are sine wave inverters. The difference is a square wave inverter will ramp up and ramp down. It's not real clean. Most electronic light devices that you plug into it will not like it. The power supplies in them have a tendency to overheat. Motors like refrigerators and everything else also have a tendency to overheat. It will run them, but you will find that will shorten the life of everything that you plug into them. So try to stay away from modified sine wave or modified inverters and stick with pure sine wave inverters, just like your current in the house. That's what everything is designed for. Next. That's some examples of cheap inverters. They do work, but like I say, they will shorten the life of your devices. Your bigger inverters, this is a sine wave inverter that's made by Outback. The inverters that we have in the house, I started off with Xantrak inverters. Xantrak has been bought out by Schneider. They still produce them. Xantrak does make inverters, but they're to the smaller type inverters. Yes, Melon? Yes, it should tell you. All inverters should be identified as to sine wave or not. Yes. The sine wave how much loss is there in a sine wave inverter? The newer inverters, especially the larger inverters, we have two 6,000 watt sine wave inverters, and their efficiency is around 95%. So they're very efficient. There is a little bit more loss in them compared to one of the cheaper inverters, but how much is it going to cost to start replacing items in the house over a period of time? So next. This is one of the first big sine wave inverters that I had. The one on the left, that was originally the Trace Xantrax, and they quit producing those, and now it's Schneider has bought them out on that. That's what's actually in the solar trailer. There's two of those. Those are rated at 4,000 watts each. The ones that I have in the house now are rated at 6,000 watts. So we have a total combination of 12,000 watts that we can produce at any given time. And they are 240, 110 output, just like your typical house current is. So you can run 220 devices off of them. Okay, 5 minutes. Thank you. One of the things that I haven't talked about too much on here is your energy efficiency. Okay, it's very important. like during the winter time, somebody was mentioning, during the winter storm that the electric bill went out through the roof. What can you do about that? Well, one of the things that we do, we also have greenhouses, which greenhouses are not insulated at all, not very well. I don't know if you ever heard of Armax. It's a foam board that's got a radiant barrier built into it. You can find it at most big box stores. I cut out panels of Armax and at night put them in the windows. If you walk up to a window and feel your wall and feel your window, even though they're high efficiency windows, the windows are cold. Most of your heat loss coming into a house is going out in and out through the windows. At night, you can cover those windows either with, we use foam boards, we just cut them and put them in there, and during the daytime, take them out, or you can put insulated curtains up. That helps, but you got to make sure they're sealed around the edges. Insulating your windows at night makes a huge difference. We have a front room, and by doing that, we discovered a difference of about 10 degrees in the morning, that it stays warmer with the boards, little foam boards that are inside in the windows. That's one simple little thing that you can do to help reduce your electric bill. We also have heat pumps. I installed heat. We have 2 mini split heat pumps. They work great as long as the temperature isn't too cold. When it starts getting below freezing, they do go into a defrost mode. These, however, do not have a resistance defrost mode. What that does is the fan inside the house shuts off. The Freon now reverses flow. The outside coils will get warm and defrost them. Meanwhile, you're using electricity, you're not getting any heat out of it. Once the coils get thawed out, it reverts back and you start producing more heat. When it gets real cold out, we have backup propane. I have a 100-pound bottle next to the house, which is the biggest bottle that you can legally put next to the house. Run a line through the house, and we have a infrared wall heater that we use. It's got 3 settings on it. They work great. We use them short term, basically early in the morning to knock the chill out of the house. You could even run them on low at night. We don't run them all night long. We run maybe in the evening for a few hours. When it gets really, really cold out, we have a wood stove. Now, it's one that I installed myself, and it has an outside air source, so it's not pulling air from the house in order to burn the fire, which causes your house to pull air in from outside. And it has tubes in the top. It's a EPA rated stove. It actually has what I call an afterburner in it. So when the fire burns and it creates so much smoke, hot air coming out of those tubes reignites that hot air, that smoke, and it burns it. And it produces a lot more heat. And if you go outside and look at the chimney, you do not see any smoke coming out of the chimney because it burns it all. Smoke is wasted fuel. But it has to be cold out in order to fire that thing up, because it'll run me out of the house. When it gets down real cold, that thing keeps our whole house nice and toasty. I get up to 80 degrees, no problem in the house when it's down to 0 degrees outside with the wood stove. So, and it doesn't suck any air from in the house. It all comes from outside. So that's another good way of doing it if you possibly can. If you have a fireplace, you can put a fireplace insert in, and you can create an outside air source for that. Fireplaces are very inefficient. It'll actually make your house colder because of all the air that it's sucking and taking out of your house. It's all going up the chimney. So use a fireplace, use backup propane. You can even use the small little buddy heaters that they use for camping that are rated for inside tents and stuff. But don't wait till the winter before you buy the little bottles of propane, because if you try to go to Walmart when it's real cold outside, you won't find any. So prepare ahead of time to get you some. The other thing you can do, if you have barbecue bottles, the 20-pound bottles, they make adapters to where you can refill those 1-pound bottles and bring them in the house and use them safely inside the house. So there's a lot of things that you can do other than electricity in order to stay warm in the wintertime. Yes. The wind, we do have a wind generator. It's a 10 kilowatt wind generator that we bought up in Oklahoma. It's made by Berge Wind Turbines. Do what? I don't know if there is or not. I don't think there is. Keep going. There may be one in the background on one of those. Nope. That's a new project that I'm doing right now. I have solar panels on the roof. My roof is 22 years old. It's an asphalt shingle roof, and it's time to replace it. I don't have to take all the panels off the roof for the roofers to get up there and do that. And our biggest solar array is on the roof. So what I'm doing is I'm going to put in a ground mount array in order to continue producing power when I take my panels off the roof. When the roof gets all done, I'll put some more panels back up on the roof, and now I have extra power to do more things with. Run water pumps, do irrigation. I mean, charge the batteries up quicker. Get an electric vehicle, right? That's one of my goals. So there's many things that you can do yourself. Do research on the internet and find there's websites that you can go to. Google off-grid solar, or in YouTube. Go to off-grid solar, do searches on what people are doing, or also homesteading. There's a lot of people, you'd be surprised how many people are moving out away from the grid where there is no power. And there's a lot of people out there showing you step by step how they've made their system and how it works for them. There's a lot of information. Yes. Right. Yes. Yes. I have a Prius, an older Prius. It's a hybrid vehicle, and I have mounted an inverter in the Prius, and I can have remote power wherever my Prius is at a limited quantity. And what happens? It draws off the battery. The Prius is automatically senses the battery voltage. When it gets down to a certain level, the engine of the Prius comes on and acts as a generator and charges my battery back up. So what you're talking about, yeah, is going to become more and more viable. And you can also reverse feed power back into the grid or whatever you want to do.
Just today or yesterday, UL and starting to put that standard
Yes.
Chevrolet, saying they're going to have 1 million cars on the road by 2030.
Do the same thing. Yes. Yeah. One of the things that do what? Oh, the statement was that the car manufacturers are looking into standardizing in order to interconnect to the grid, so that you can use your car not only to charge your battery in the car, but also in case of emergency, or if the grid requires more power, that the batteries in the car can automatically power part of your grid or your house at the same time. It's two-way interchangeable, and they're trying to look at standardizing that for all the manufacturers. Is that correct? Yeah. One of the problems that I had with my utility company, I'm on a co-op, I can't switch, so I can't find cheaper power. I did not like their net metering policy. They wanted too much money up front, and they wanted to charge me to put power onto the grid. I decided to disconnect from the grid. Now, I still do have power at the house, and what I have done is I've completely disconnected the house from the grid except for one item, and that is a backup battery charger. I have one item. I used to, for 6 years, completely disconnected everything from the grid and ran the house just fine. For 6 years, we used a generator from time to time during the winter time whenever the batteries got low for lack of sun or lack of wind, we use the generator from time to time, which are noisy, they pollute. I didn't like it. I discovered that if I use the grid just to charge batteries, it's a lot cheaper than running the generator. I don't have to haul gas, does not make any noise. So it's a very efficient way for me to use the grid. We don't use it every day. It's just from time to time. It's a backup power. And still, if the grid goes down, I still can connect that battery charger to my generator to keep my batteries up. So it's multiple different sources of power, whether it's propane, gas, solar, hot water. We do have hot water in order to be self-reliant and maintain your way of life.
So if anyone
So-
wants to get a hold of you, talk about going off grid or being more
Through the North Texas Renewable Energy Group would be the best way. There's articles in there on my system. If you want to leave a message and talk to me, I do, give out advice of what can be done. I don't know, maybe somebody out there, if you send a message to somebody, then get a hold of me. I do not want to give my email address out and phone number out to everybody in the world because I just get flooded with everything. So if you want to get a hold of me, contact somebody at the North Texas Renewable Energy Group and then get a hold of me and I can call you back. Yeah, that would be another source. If you go to the group discussion page, yeah, I can. And if you specifically ask me a question on that group, if I'm looking at it, I can try to answer your questions or get back with you. That would be another way of doing it. Thank you for that, Melanie. I forgot about that. And it's interesting to watch the conversations that go on the group discussion. There's some very interesting and helpful information and ideas out there on that. I think my time's up. Thank you.
Thank you for that very information dense presentation. I'm sure people may have additional questions. I know I do. So I like the idea of just going to the NTREG chat room and posting questions that way, just in general, and he can respond, or other people that may have input can also respond. Before we get on the roof and before we end the meeting, one or two announcements. The Oak Cliff Earth Day is 3 weeks from tomorrow. And so we're going to have a booth. We need some volunteers. I know I'll be there. I have a bunch of LED bulbs I need to give to you. And so we're looking for volunteers. We need ideally 3 or 4 people there. It's from noon to 5. And I'll probably be there the entire time. And I don't know about some of the rest of you, but please, I guess we can put some sort of sign up sheet maybe on. Okay. 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 So okay. So the yeah, we will send out a message about the sign up. Robert. Yeah. Okay. So third. Yeah. Oh, okay. 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 So next month, again, we're going to have the meeting here. Looks like this will be our meeting place going forward. Again, we're going to have it hybrid, so anyone that can't physically be here can still just tune in or log in to the meeting. But we're going to have a gentleman from the Federal Reserve Bank of Dallas making a presentation to us. Hopefully, next month, we won't have the technical difficulties we had today, and we'll be able to start on time, and so we can have the normal board presentations that we typically have at the start of the meetings prior to the presentation. With any luck, we'll do that. At any rate, hopefully we will see all of y'all here next month, and maybe some other people that are currently attending online will be here as well. And then also, please, anyone that can help out or contribute at the Oak Cliff Birthday Fair in 3 weeks from tomorrow, please do so. You know, we accept whatever help we can get on that. With that, I think we're probably kind of running out of time. Yes. Yeah.
Okay,